Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, today we are going to discuss intermolecular forces, which are also known as the van der Waals forces. Before explaining intermolecular forces, we have to look upon different types of forces that exist in a molecule. Basically, there are two types of forces that exist in a molecule. These are intramolecular forces and intermolecular forces. Intramolecular forces basically create a molecule, that is, atoms held together and form a molecule. Atoms that react together to form a molecule, these atoms join together with a force that is known as the intramolecule. These intramolecular forces you have previously studied under the headings or names of ionic bond, covalent bond or metallic bond. These forces are very much stronger as compared to intermolecular forces. It determines chemical behavior of a molecule, and they are categorized into ionic, covalent and metal bond. The other type is intermolecular forces. Intermolecular forces exist when a molecule is formed. Now this molecule attract or experience a force of attraction with the other its neighboring molecule. This force is known as the intermolecular forces. That is, force that exists between molecules. Then they are weaker as compared to intramolecular forces. These intermolecular forces determine the physical properties of the molecule. They can be categorized into dipole-dipole forces, London dispersion forces, dipole-induced dipole forces and hydrogen bond, like which you can see in your book, that is dipole-dipole forces, ion dipole forces, dipole-induced dipole forces, London dispersion forces and hydrogen bonding. In your book, you will study dipole-dipole forces, dipole-induced dipole force, dipole-dipole forces, London dispersion forces and hydrogen bonding. First, we will discuss dipole-dipole forces. Dipole-dipole forces, before we explaining our topic dipole-dipole forces, we have a look upon your previous knowledge, that is the types of molecules. You have studied that there are two types of molecules on the basis of their covalent nature. One is the polar molecule and other is non-polar molecule. Polar molecule, covalent compound are said to have a polar nature when there is electronegativity difference between the bonded atoms or between the molecule. That is, there should appreciable electronegativity difference between the atoms. Then atoms which is more electronegative attract electrons more towards itself, and it got a partial negative charge, and which is also known as slightly negative charge, and the other end which is deprived of electrons or have less electron density get a partial positive charge. Then polar covalent molecules has two center of charges, so it is known as the dipole, and definitely these are, one is partial positive end and the other is partial negative pole. For example, CHCl3. Second is the non-polar molecule. Covalent compounds are said to be non-polar when electrons are shared equally among atoms, when there is no electronegativity difference or very slight electronegativity difference, then molecule is said to be non-polar. Electronegativity difference may be 0 or very, very low. Then there is a no charge separation in non-polar molecules. Definitely when there is no electronegativity difference, no charges will be created and there will be no separation. For example, Cl2, Br2, F2 and like other non-polar molecules. Now, dipole-dipole forces are present in polar molecules. Dipole-dipole forces are present in polar molecules. Like how they are present. You have studied HCl molecule. In HCl molecule, chlorine is highly electronegative, so it attracts the shared pair of electron more towards itself and got a slightly negative charge. As a result, hydrogen got deprived of shared pair of electrons and got a partial positive charge. In simple way, we can say that hydrogen has less charge density and chlorine has more charge density. There is another HCl molecule on the same basis with hydrogen partial positive and chlorine partial negative charge. Between these two HCl molecules, the negative end of one molecule attract the positive pole of the other molecule, and there is a force of attraction. This force of attraction between these two oppositely charged atoms is regarded as the dipole-dipole forces. These are regarded as the dipole-dipole forces. Now, the next is these dipole-dipole forces are also known as electrostatic interactions. Electro means charge. As we have studied that these molecules have charge on it, so it is regarded as the electrostatic interactions. Now, the next is how these dipole-dipole forces affect the properties of the molecules. These dipole-dipole forces affect the thermodynamic parameters of the molecules. Like if these dipole-dipole forces are very much stronger, then it will increase the melting point, boiling point, heat of vaporization and heat of sublimation of that molecule. I hope you have understood today's topic. Thank you.